Doctori, tutto a posto? Welcome back to a new episode of Sane C++ Libraries. That is a set of C++ platform abstraction libraries for macOS, Windows, and Linux that focuses on fast compile times, being bloat-free, simple and readable, and easy to integrate with no use of the C++ standard library and no third-party dependencies. That being said, you can go and check it out on GitHub and just, have fun with it. Get in touch with me if you want on the Getting in Touch section. And this means we can proceed to do what we wanted to do today, which is here on our Xcode. Last time I have been implementing this ZLib transform stream, but it's like a synchronous stream. It's not that bad, that difficult. I mean, I wish there is a little bit less things to write, but maybe I will simplify the API later on. This is not so bad. So what I would like to do is now transform this into async state machine. And this would be very easy with the use of, async await keywords, but it would not be as fun, of course, as doing it manually. But also, I would like to do it completely with no allocation at all. And this is not guaranteed with the use of async await, which is one of the main problems about async await, in my opinion. That being said, how do we even do that? The first thing that I would like to do is one consideration that I have been making already in the previous episode, in the previous video, just this is not strictly a transform stream. It is more like of a duplex stream. So let's say I really would like to rename this as a async duplex stream, because that's what it is. It's it's a duplex stream. Actually, maybe this one should not be here if it's a duplex stream, but it should be into the derived class. Yeah, that's probably better. So our ZLib stream needs to bind the async readable stream by itself like this. Does this still work? Oh, I have the full suite going on. Let's make sure it's not like that. So I will just be executing the async request stream test, which is our go-to test for all of these async streams. Fair. This works. So we have not been breaking too much stuff. Now, how do we make like an asynchronous state machine out of this? Let's put it side by side so that I can go into my async streams.h and create my struct async transform stream, right? This becomes derived from async duplex stream. Okay. Let's say we have an enum class state. We have some states. I guess we can have a known state. Well, we'll see. I guess we have a processing state, a finalizing state, finalized state, maybe even a paused state. Yeah. So the known state is basically when we get called the first time here, right? And we will do the following stuff. Then we will have the processing, we will be getting the buffer. And before going here, that's where we transition to the processing state. Or if we were not able to get a buffer, that's where we go into the paused state. Actually, I can probably we use the states from the readable side, but it's, I don't know. I think it's easier to track it on the class itself, and let's see if this works. Well, if you see this video, it means because it works, because if it doesn't work, I will just discard the video. But let's see how it goes. If this is one of the good videos where I'm lost. I'm lost. Okay. And then I have the finalizing state, which is here. Basically when I'm calling the finalize. And I have the finalized state, which is basically here, which is after the stream ended, right? Okay, let's say we have, so I need to place myself here, async transform stream, and I have async transform stream, async transform stream, async, so we need to do async read. Yeah, let's do the same. Let's copy this one, because at the end of the day, that's our starting point. So I can have a transform and then can end transform, right? That's our signature. Maybe we can remove all of this namespacing. And can end transform, what's the signature? This one. Okay, can end transform. Oh, no identifier self. Well, using self to be async transform stream. All right. Now, of course, it's complaining that we don't have defined bot can end transform async transform stream. So I need to define bot transform, which is this guy that returns result true. And I need to define async transform stream can end transform. Can end transform can return result true. Actually, no, this is just a Boolean. Let's say we return true. Okay. Auto line, yes, of course. What's wrong? Oh, I just unused parameters. Beautiful. So we have our state machine switch. We need a state event, sorry, state variable, state equals state known. We switch on the state. So in case we are in state known, what do we do? First thing we do, so we have to copy this. We need to take our source data and input data. Okay, well, I guess the problem here, I was needing to have this consumed input bytes because, yes, because here this function was not really keeping track of the state, but here I can just say input data. Now it's one of my fields, and this becomes my input data, and I don't need to track the consumed bytes, right? So I have all of this preparation phase, which I want to call like prepare. So let's prepare this. And I need to save buffer ID and callback. So let's say this one is my input callback, because this is input data, even if this is the right callback. But let's call it input callback, because that's our input. Of course, input, output, it's all a perspective. Depends on who is looking at what. So, but from the perspective of the transform, that's my input callback. So that's the callback that comes with my input data. Even this comes from the writable side. And what else I need to do? So CB, so input callback, move CB. And I need to save, do I need to save the input buffer ID? Yes, because I need to pass it to the callback. So I need async buffer view ID, input buffer ID. So input buffer ID equals buffer ID. So what is now to be done next? Prepare. And I need to declare it. Result, prepare. Return result true. Okay, return result true for enumeration values not handled. Pause. Sure. Let's add them. What other state can I be called for a transform? I can be called definitely when I'm pausing. And in that case, my input buffer ID and callback are already what they are. So I can just return prepare. And in all of these other cases, this is just unwanted state. Well, I will maybe return a more descriptive error later on when cleaning this code, but for now, that's what I want to do. Okay, now prepare. Prepare, I need to take my output data and my output buffer. So that's what I need to do. So you see, we are just going one by one and turning our synchronous code into this state machine. So output data, output buffer ID needs to persist. Yes, because when we will be calling process, this will be potentially a call that will end later on. So I need to persist the value of both the output data and the buffer ID. And that's what like async await is doing. You know, it does like a compiler transformation, and it's taking this code and putting it to this frame that it's later on, restored when the control goes back here after a resume operation. But what we are doing here is placing all of this data into our initial object, and into our object that is keeping the entire state for the transform. So we don't allocate, or we just allocate once. Actually, it's the user that decides if they want this async transform stream to be allocated somewhere or dynamically allocated, but it's not us. So we are not like adding any allocation to the process. So we have two cases here. We can get a buffer, and if we get a buffer, we don't need to track this anymore, I guess, because we can now I need to create an event, right? So now I need to abstract this processing of input data and output data. So I'm saying function What is this? This is a function returns a result, takes a span of const char, and outputs a span. Oh, you know what? I don't need to make it reference because, yeah, because this function will need then to call like an after. You know, a function that says, yeah, I have done the process later on, potentially later on. For now, and I think we will just be mapping again to the synchronous processing, but later on, this can spawn like a thread and return at a later moment. So it's say on process or just process and finalize. Do I already have a finalize? No. Finalize. And the finalize just has the output buffer. So the after functions, how do they look like? They will need to be after process, right? And you will have the updated input and output buffer. Let's say input data after, output data after, or just input. Well, no, that's all right. And what do I call this? After finalize. Output data. Well, maybe data is not needed. It's just input after, output after. And here we also need to be passing the other famous flag to know if the stream was ended. Bool stream ended. Okay. So let's put them here. And let's try to implement them. Unused parameter. So what happens after? After process, we need to check the consumed input. So consumed input and consumed output. So consumed output will be output before, which is just our output data, minus output after, which is this guy here. And if consumed output is bigger than 0, we just push the output buffer, right? What about the input? Our input data now needs to become our input after. And if input data, we break the loop when the input data is empty. So if it's empty, what do? We do this, right? We don't have the consumed input bytes, so our callback copy is the input callback, well, which we already moved. Input callback. But you know what? Let's do like this because I'm not sure if something is reentrant. I've had so many problems with this, and so every time now I have a callback, I just use this pattern. I don't know if it's needed everywhere, but that's what I'm doing. So what buffer should I be passing? This is my initial input buffer, which was input buffer ID, the one that we saved initially here in the state known. And what about the after finalize? In the after finalize, we have all of this fancy stuff. So, okay. We of course have the consumed output, and if consumed output is bigger than 0, we push n, and we have stream ended. After finalize, We push and we go in state finalized, right? Okay. This looks reasonable. Now, I have unref buffer also here. After pushing, right? Here. Now, when preparing, if let's do the good case. I have my output buffer, so state is processing. If my state is processing, I can just process. I have input data and output data, right? And if not res, well, maybe I can just try async this guy. Okay. Yeah. And I have something similar even in the canon transform. So, but instead of calling process, I'm calling finalize, and I'm finalizing just with the output data, because now we have consumed all of the input data, right? Good. So in the good case, we are calling the process. What about the bad case? Bad case, we are in paused state. I know we have paused state already in the writable, but we have this double inheritance. I would like just to avoid being confused, and for now I'm keeping a state that is local to the transform stream. If I'm able later on to simplify this a little bit, I will try to do it, but for now that's what I'm going to do. And the same as canon transform, where we are placing ourselves into a paused state when we are unable to get a buffer. So far, so good. So when we come back here, oh, we still need to unshift. Where do we put the unshift thing? I don't even know if this stop was needed at all at some point. Is this needed? No. Okay, so we can probably remove it. And why did I remove the unref buffer? I also need to unref the buffer here. Yeah, that's more correct. So when this is failing, that's what I need to do. Buffer ID is my input buffer ID. This is my input callback. And you know what? I'm also cleaning them up. So I'm sure I'm not doing anything. Well, I can keep them because maybe I can double check here. Yeah, because at this point when I'm resumed, I know I need to get a buffer ID that is equal to this guy. So let's say wrong buffer ID. Yeah. One less case to consider. And what about the end? The end does not need to place anything back because it's just finalizing the output buffer. So there is no unshift to do. The input buffer, it's already gone. When we are in the ending state, sorry, in the finalizing state. All right. I think this has some bugs, but I I don't think I will be able to figure them out just by staring at the code. So let's try to create, oops, let's try to create, you know what, let me close this for now. So I have more screen space. Let's try to create this struct async ZLib transform stream, public async transform stream. So I will still implement it as sync stream at the end of the day, but I want to see if the logic of this entire state machine makes any sense. So let me place it below. Well, I always like to separate them with a comment. Okay. Async transform stream. I need to redefine the process function. I can even use a lambda probably. Let's use this lambda, and we have a span const char input data and a span char output data. We need to grab the this pointer. We have stream dot process. Input is input data, output data. Yeah, this needs to return result true. And otherwise, we just call async transform stream after process. Input data, output data. Let's rename output data properly. Output data. Okay. What about finalize? Finalize has this single output data parameter. Finalize. Bool stream ended. We pass the stream ended. Stream ended. So if the stream is ended, we will make sure to tell it to the async transform stream after finalize output data stream ended output data. All right. So in my test, I just need to replace all of this sync ZLib transform stream with async transform streams, right? And let's see what happens. Go. Unwanted state. Were you expecting this to even work? No. Let's be serious. Someday it will happen. Someday it will just work. And of course it will be completely wrong, but it will look like everything is working. Let's try to diagnose what's wrong. So which state is it complaining? Let's see. Oh, where is it? Oh, I've not been giving it any name. Well, we can place ourselves into any of this. Oh, so it's resuming while we are in state processing. Okay. State processing. So here, right? Are we even getting to well, yeah, but once if the input data is empty, then we need to go in state known. Or not. Yes. You need to go in state known because on the next buffer, we need to grab the next buffer ID and callback. Yeah. State known. You know what? Here, I'm probably better just cleaning all of the input buffer ID, input callback. Well, maybe after grabbing it, which I'm already doing. But also the output buffer ID and the output data. Let's try. So I'm going here. Okay. Unref buffer. So we are doing something bad with the unreffing. What am I doing wrong? I'm unreffing this buffer. And after process, so I'm getting the buffer and I am unreffing it here, which is good. You know what? Maybe I should be doing this here. And in the finalize, I am unreffing the buffer after pushing it. And also here, I should be probably be cleaning it up like this. But I don't think I'm doing something wrong. It may be here. Oh yes, this is wrong, of course, because I've not been getting a buffer at all. If not, yeah, let's do like the result process, not result. That's where I need to release this buffer. Yeah. And try async result. Try again. Completely wrong. After write, so this buffer has been released. Oh, it's a completely invalid buffer. That's bad. Input buffer ID. I mean, this could be a problem if you reset the input buffer ID even before. Well, I should not be touching it at all. Okay, let's try again. Destination size. Okay, well, we're getting better, but still doesn't work. Let's see. I am now, let's see, how many times am I getting even into this process, and I'm getting finalize. Stream ended is true. So I'm going in the after finalize. If stream ended is pushing n. Oh, it's never being ended, right? So let's say we switch, depending on the state. In which state can we be even ending the transform? We can be in like state known. What other states do we have? Well, let's have the compiler tell us all of the states and make sure that we can end the transform in the proper state. So if it's finalized, we can just return true, right? If it's finalizing, we cannot end the state, so we return false. If it's none or paused, can we even be in processing? Probably not. So processing, it's an error, I guess. Result error, wrong state. And yeah, and here, well, if we have someone synchronously changing our state, we may be passing from state none or paused to state finalized. And if we are finalized, we can immediately end the transform. So this code needs to go somewhere else. How do I call this? Result try finalize. Is it even volleyball? No, I can make it void. Prepare, where is the prepare? I can put it side by side with the prepare. Well, maybe, yeah, these names are not great, but I don't want to waste time naming things right now. I will eventually rename them later. So prepare, no, not prepare, try finalize. And in try finalize, that's what we're doing. Okay. Let's try again. Oh, this is a breakpoint. Let's remove all of them. Go. Still not going. So let's see, are we even arriving here? No. Am I registering for the can and transform? So this is try finalize, state is finalized. That's where I'm going, right? Let's check what's the state. State is finalized, so I'm actually finalizing it. Okay, something is wrong. What's wrong? This looks decent. And am I updating? You know, after finalize, yeah, output data needs to become output after. And only if stream ended, I need to, yeah, release the buff. Well, I mean, does this make even sense? Because when finalizing, either I'm finalized or I will need to get a new buffer anyway. But more importantly, even here, I need to do, yeah, my output data becomes output after. Let's not clear this output buffer ID maybe. Oh, this doesn't look like it's needed because when returning in the state machine, I will be back into the known state to get a new buffer. Where am I even getting the, yeah, in the prepare, right? Where am I getting the output buffer data and output buffer ID? Here. Yeah, so this doesn't look like it's needed at all. I just need to keep track of the input data. And only when the input data is empty, I'll go back to state known. That will bring me back here into getting new piece of input data. I don't know why this is not going. So what's the destination sides? It's 412, and it's not the correct sides. So it looks like we are not writing one of the buffers. Let's probably the best place to see what's going on is here. So we have a first process. We go into the after process. We push this, unref it. Input data is empty, state is known, which is fine. We call the callback. This means that at some later time, we will be going back here into the known state, right? Because we are in known state. Okay, we get next input data, we save it, and we prepare, which means we get the buffer. Processing, we process the buffer. After process, we unref it. Input data is empty, and it's finished writing. This looks decent. Now we should go into the can end. Oh, why are we still in the prepare? Who's calling the prepare? So we are still in a known state. Do we still have data to transform? Yeah, this is empty. Do I need to filter this? Let's look at the synchronous code that is working to figure out if we are doing something different. Okay, we can get called with input data that is empty, and in that case, we just say finish writing. So I should not go into the prepare if input data is empty. This looks not so bad. But I'm wondering if, when and if we are getting there. So input data, process, input data, process, input data. This is not empty. We still have two, process, then can and transform. We try to finalize. We get this output data where I'm finalizing. We finalize. After finalize, output data, consumed output. We push it, unref the buffer. Stream is even ending. So we push and state is finalized. Oh, and we are getting another try finalize. No, that's just leaving our previous call. That's wrong. After finalizing, we are, well, but this may be the other stream, okay? Oh. State processing. We are getting a can transforming state processing here. Why is that the case? Oh, this should not be returning an error. It should just say yes or no. So when we are processing, can we transform? No. Why are we even getting that? That's actually, that's actually wrong. I've moved this to the other screen, sorry. Input data, process, input data, process, input data, process, can and transform, finalize. Now this is the other input data, process. It goes immediately into can and transform. No, we cannot. So now we are going into the finalize. Okay. Yeah, so maybe even when processing, I need to finalize. Okay, let's try like this. Yeah, because it's asking me to finalize. No, it doesn't work. It doesn't work. So I'm getting my first finalize call. How much time are we into this video? 46 minutes, not bad. So try finalize. Try finalize. State is finalizing. Okay, so it wants to finalize multiple times. And of course, yes. So maybe that's what I need to do. Finalizing. Where am I placing myself into this finalizing state? Oh, so this is when it's running the finalize. Yeah. Because when finalizing, I need to say false. I'm getting lost. Sorry, finalized is true. When finalizing is false. And maybe when processing, I need to do this. I'm getting lost somewhere. So after process, if input data is empty, then we are in state known. Otherwise, we are in state paused. And after finalize, I'm not sure if I need to be in state paused or known. Now I'm just going random. So here I definitely need to be in paused state because they need to come back to me with, you know, maybe I should do the unshift. Yeah. The same as I'm doing here, right? Because if I've not been consuming all of the input data, should I? Let's see if I'm even getting here. Yes. Well, I don't know. Let's compare this with the synchronous version. Okay. So we get the data first. We are in known state. And we get the input data. We are saving the callback and the buffer. Otherwise, we prepare, which is this preparation phase here before processing, where we are doing this exact same thing here. And then we are calling process, going in the processing state. And we just report the error and eventually unref the buffer if this is going on error. Well, this is probably not. Yeah, I would need to track the state here, but I don't think that's going to hurt. Otherwise, we go in the after process. We check the consumed output, eventually push a buffer, and we unref the buffer. We don't need to save this, but we do it anyway. And with the new input data, so if the input data is empty, then we go back in state known to receive the next one. And we say we are finished. Otherwise, well, you don't need to unshift because well, we do. Otherwise, we will not see the transform getting called again. So I'm moving the input callback. So this means that I need to save them again here. So paused and known are basically the same, with the exception of my input data persisting. Okay. Now, when get buffer of pause is failing, we unshift, we unref the buffer, which doesn't hurt. We can even do it before because well, this makes no sense because output buffer ID does not exist when this fails. So this makes no sense. This makes no sense. I don't think that this is, of course, I don't think this is our problem. Then, so in the after process, we are pushing. This looks correct. We are in state known, otherwise we are in state paused. This looks coherent with what we are doing here. Oh, here we are finalizing, maybe. No, we are paused because finalizing is when the finalizing callback is being called. I don't know. So I've tried so many things. I've tried so hard and got so far. But in the end, it doesn't even matter. So where can I fix this? I think the answer is still at looking what we are doing here. So when the get buffer pause is failing, this is unshifting, which is correct. And after process, well, this other unshift doesn't look right, because I do not have here in my synchronous version. So when the input data is not empty, so when the input data is empty, it will go here. And when it's not empty, it will loop, right? Okay. Looping, what does loop mean? It will call again the transform, right? Yeah, because here it's calling process. Or should I call the process? What should I do? Oh, I should call again this state machine, right? So let me try to do that. Transform. Okay. Beautiful. Okay, that was it. Yes. I don't know why I was thinking that calling the unshift here was a good idea, but yes, it was more transforming. That is what I need to do, because when the input data is empty, if you see here, when it's not empty, we are looping. So it means going again into the basically decisional process that is being done here, which means again moving the input callback and input buffer ID and then calling prepare again. I mean, I could call probably prepare again myself, but this works as well. So yeah, this was pretty long, and I suspect I will need to cut a little bit the section where I was just stuck and I could not really figure out what was going on, because this has been taking a while. So depending on how long the video will be, maybe I will cut it, but we'll see. Maybe I can leave it so that you can see how much I'm struggling when doing these things. And that's everything for now. So let me recap what I have been doing. I have been taking this synchronous transform stream and transforming it into like a state machine where my process and finalize can be re-implemented as, you know, lambda functions, such that they can, for example, spawn a thread here, which I'm not doing, but I will. And after the thread is done, I can call the after process on the main thread on something that is able to go in the same thread that is running the transform. And I can continue and step my state machine. And the same for the finalize. So for now, I have implemented it as a synchronous stream, basically the same as before, just to make sure that the logic of the state machine, which is already pretty complicated, as you can see, to make sure it's right. So I will commit things as is, just as my stable point. And I guess next step will be trying to implement this as an actual proper async operation here, which means creating an async loop work and pushing the work over a thread. But that's all right for today. So I hope you enjoyed this video, even if there was a very long debugging section. And yeah, these things are not easy, but that's what I like doing for now. And enjoy and see you next time with Sane C++ libraries.